All right, question number 11 continues to deal with the idea of the law of multiple proportions. So let's read what we have here. Fluorine and xenon combine to form two different compounds. All right, so fluorine is an F, so fluorine plus xenon gives us compound 1. All right, so let's see. In one compound, 0.853 grams of fluorine combines with 1.472 grams of xenon, all right? And then in the next compound, all right, so I'm going to bring this one down here. So fluorine plus xenon making compound 2, which we know it would be this, but we don't know how much of it makes it up. So in this compound, we have 0.624 grams of fluorine is combining with 2.16 grams of xenon. All right. And so then again, the question, so we've got all four numbers are different, right? Again, the question is, do the data support the law of multiple proportions? Okay, so again here, because all four numbers are different, we need to find how these numbers compare to each other, right? So that we can then compare what's going on here. So let's look. So for compound number 1, we have I'm going to take these two numbers. I'm going to take the smaller number and divide it by the bigger number. So 0.853 divided by 1.472. All right, I'm just getting just the actual division of that. So put that into your calculator, and I got 0.579. Please stop the video and do your own calculation and see if you get the same thing that I'm getting. Now this is fluorine to xenon, as we're doing here. And so I need to go in the same order, so I'm making the same kind of comparison, right? So then in compound 2, it is 0.624 grams of fluorine to 2.16 grams of xenon. And so since I'm just getting pure numbers here, then when I put that into the calculator, I get 0.289 is my ratio. Now, this tells me how these two are comparing to each other. And now it tells me how these two are comparing to each other. So now I need to do this additional thing here and compare these two, okay? So since I'm going to just do compound 1 to compound 2, so I'm going to go 0.579 divided by 0.281. I do that because really I'm dividing. I want to divide them both by the smallest, because if I do this, that would give me 1, and that would be the ratio, right? So this one divided by that gives me some number, and that divided by that gives me the number 1. So that's how I could write the ratio. So when I put this in 0.579 divided by the smaller one, this gives me the number 2. Now, was it exactly 2? So let's look at this. So 0.579 divided by 0.289 equals, okay, so look at this. It's not 2 exactly. But in rounding, look at these. I can't keep those numbers, right? That's just way too small. So I can call that 2. I can call that the whole number 2. So that being a 2, yes. To this question, the data supports. So LMP is supported. Yes, because we ended up with a whole number based on these ratios. And I would say that the ratio is this. So here we go. Since what I was saying was divide by 0.289, divide by 0.289, right? So this ratio would be 2 to 1 for the xenon. That's how we can, that's why we choose to divide it by the smallest one. So we get a 1 for one of our numbers, okay? So I kind of smushed that together there, but that's what we're doing. All right, yay! That's another one of those. Let's go on to question number 12. question number 12. All right. 12 says that we have a chart again. So it says ferric chloride is 34.4% iron, and it is 65.6% chlorine by mass. All right. A chemist analyzes 3 compounds that contain iron and chlorine. Her results are summarized in the data table below. All right, so I'm going to bring this over. So here is the data table, right, for that you're going to be looking at. So we have 3 compounds, and they have different amounts of iron and chlorine in them. And the sample sizes are, so 2 sample sizes are 25 grams, and 1 sample size is 27 grams. So what we're being asked is, so this is what we have inside. This is the percentages if the compound is ferric chloride. Okay? All ferric chloride has, no matter the sample size, all ferric chloride is 34.4% iron and 65.6% chlorine. That's what it told us. So now what we have to do, guys, is we're going to take the information from the chart and just sort of work backwards and see if we get these percentages, right? So here's how I set this up. And here's the thing. There are only 2 compounds here, right? Iron and chlorine. So if I can get the iron to match this percentage, then I know that the chlorine has to be this percent. It can't be anything else, because those are the only 2 things in there. So I'm just going to do the iron. So I'm going to take the first mass. So in compound 1, the mass of the iron, right? So how do we get percent mass, right? Equals the mass of the iron was 9.3 grams. And the mass of the sample from the chart is 25 grams times 100. So I'm going to pick up my calculator, and I'm going to go 9.3 divided by 25 equals times 100. And that is, that percent by mass equals 37.2%. Can this compound be ferric chloride? No, it cannot be, because ferric chloride has to be 34.4% iron. This is 37.2% iron. So no, that one is eliminated. It cannot be ferric chloride. Let's look at compound 2. Compound 2, again, percent by mass equals the mass of the iron in this compound is 8.6 grams. Oh, 8.60 grams, sorry. And the mass of the sample is 25 grams times 100. All right, so again, pick up my calculator. 8.6 divided by 25 equals times 100. Ooh! The percent by mass equals 34.4%. That number matches that number. Check. That one can be the iron chloride. All right. Let's look at number 3. Here we have percent mass equals this sample size. The iron is also, remember, all of the data that I'm using is in the chart, right? Okay, I know you couldn't see that. That was really, somebody said, well, we did this before, but look, the sample size is different. This sample size is 27 grams times 100. All right, so let's see what we get. All right, so 9.3 divided by 27 equals times 100. Yay! Percent mass equals 34.4% iron. This was, yeah, iron. So check this can also be a sample of ferric chloride. Now, you would say, well, how do we know that the chlorine is the same? You could do the work for the chlorine, but we could also subtract, right? So if we have, 100%, right? 100%, 100 minus 34.4 equals 65.6. So if 34.4% is the iron, then 65.6% has to be the chlorine, right? So we don't even have to do the work, or you could have done the work for the chlorine if you wanted to. It wasn't magic. All of you could have chosen chlorine to work with. Any of that, either of those would have worked to get us the answer. So this compound 1 cannot possibly be ferric chloride because all ferric chloride has this composition, no matter the sample size, all right? So we can eliminate this one because we had the wrong amount of iron in it, and we would also have the wrong amount of chlorine in it, all right?